Hello, my name is Al Amin Hussein. I am here to present our paper titled as Hand Pose Guided 3D Pooling for Word Level Sign Language Recognition. Here are the list of authors. Let's start the presentation. Given an input representing an isolated sign word as a video, our goal is to train a machine learning model so that it can understand what class video is this. For example, here we see two classes of sign videos. One is work, another one is cook. So we expect that after training, our machine learning models can distinguish between these different types of videos. One of the motivation of our work is if we have a system like that, we can use that in searching similar videos from the online and use them in many other applications. Another thing is that we can use that type of sign language interpreter as an interface to the voice controlled assistive technologies such as Apple Siri or Amazon Alexa, those kind of thing. One challenges in modeling sign from video is that people tend to use their own style while doing sign. And so as you can see, here is the sign of CD from three different people and they tend to differ. And the other thing is that some sign has like smaller motion in them, but clearer hand shape, and other types of sign, they might have complex hand motion. So we need to take this into account while doing machine learning model on this type of data. In our approach, we observe that hand shape is the most important thing in recognizing sign language. So what we do, we want to use as much information possible from the hand shape region. And we propose to use pose to do that. For example, we can see that here top is a video, and we can see that there are four feature maps from a 3D convolutional neural network in the bottom for the same video. Now what interesting is that if we know the pose of the video, we can pinpoint the location of hand in the feature map space. When can we do that? We can extract some features from there and use that in our classification. On the right hand side, we show the equation which we use in converting pose from video space to feature map space. So this is our overall architecture look like. So we have a I3D network, which is a well-known video recognition model, but we also give input pose with the video. Now pose is not used in the max pool or any transformation. Pose is used only when we decide to extract some features from a localized position, like from hand. So as you can see, from different branches, we train different classifiers using that localized feature. And during test time, we fuse their scores and get our final scores. This is the data set we used for the experiment. So this data set was recently introduced and it has four subsets based on the number of classes they have. More details can be found in the including paper. Here are the results. So we saw that our best results were achieved by fusion 3, which is a fusion between four branches. And we got like almost 10 to 12% improvement in different subsets. One also interesting thing is that when we look at the PPC8 or PPC7, so these are only one branches classifier. So these are also having good classification accuracy than the baseline I3D. And we assume that this is happening because of our post-pull features, because our post-pull features is more localized to hand locations. Here is some quality findings. First of all, we wanted to know that how our learned feature transferred to similar tasks. So that's why we fine-tune our model with another data set, and we saw that using only 0.4% of training data, our method beats the normal I3D by 11% in accuracy. The other thing we noticed that the sign with lower motion tend to better captured by the post-pull classifier. This is true because the sign with low motion has more visible hand shape patterns, and since our post-pull method takes information around the hand shapes, so that's why they classify those signs better than the normal I3D. More details can be found in the paper. Thank you for listening, and I can take some questions now.